Hi everyone. So we're going to jump right into our next problem solving strategy of draw a diagram. And hopefully you guys have actually already given this one a shot. I posted it right before this lecture video so that you guys could take an active role in trying to solve it. So why don't you grab what you've done and make sure you have either your guided notes or a pencil and a piece of paper so that you can jump in with me and we can talk about how to solve this problem. Once again, following along in the book, we are in section 1.2. So what exactly are we doing when we use this problem-solving strategy of drawing a diagram? That means we're drawing a diagram or a picture that represents the data or the information of the problem as accurately as possible. And so our diagram does not have to be overly complicated. You don't need to be an artist in order to do it. In fact, today we're going to use a very simplistic version of a diagram. We're just simply going to draw a number line. So whatever will help you solve the problem as efficiently as possible in a way that makes sense, that's the diagram you draw. So draw whatever grab whatever diagram you drew for the problem that I posted, and let's jump in and get started with that. Let's take a look at our problem. In a stock car race, the first 5 finishers in some order were a Ford, a Pontiac, a Chevrolet, a Buick, and a Dodge. And then we're going to be given some clues. So the first clue is the Ford finished 7 seconds before the Chevrolet. The Pontiac finished 6 seconds after the Buick. The Dodge finished 8 seconds after the Buick. And the Chevrolet finished 2 seconds before the Pontiac. In what order did the cars finish? So again, we've always got to go back to Polya and his problem-solving principles, the first of which, if our mnemonic is continuing to help you, I hope it is, we know that our first problem-solving principle is understand. So do I understand this problem? We should always take that minute to reflect, ask ourselves some prompting questions, and at this point, I'm going to encourage you to pause the video and do that on your own. If you need to reread it, go back through it, just make sure you understand what the problem is telling you and what you're being asked to solve. Our next problem-solving principle is to plan. We need to make our plan, and I've already told you the plan we're going to use here. We're going to draw a diagram, but again, at this step, you always want to pause and reflect and think about, okay, what in my toolbox of problem-solving strategies, which one should I use to help me solve this problem? So once we have our plan, of course, we have to execute it. So hopefully you have your workout, something to take notes on, and we're going to try and solve this problem together on the next slide. Execute our plan of drawing a diagram. Okay, so you can see I've got my little finish line here on the right side of the slide. So that's where my cars are going to finish in my diagram. And what I'm going to wind up doing is I'm going to use just a little number line. And I think oftentimes, again, just like guess and check sort of tends to be overlooked as a problem-solving strategy, when we think about diagrams, we don't always think about a number line. But a number line is a type of diagram, and it's a very useful type of diagram. Simplistic, easy to work with, and very efficient. So I'm going to draw my number line, and I'm just going to wind up plotting these cars on a number line. So let's go clue by clue here. The first clue says the Ford finished 7 seconds before the Chevrolet. So if the Ford is finishing before the Chevrolet, that means the Ford is closer to the finish line. So I'm just going to plot a point here from my Ford. And then since I know that it's 7 seconds before the Chevy, I'm just going to jump back 7. 1, 2, 3, 4, 5, 6, 7, and there's my Chevy. So each one of these little tick marks on here represents a scale of 1 second, and that's important to think about. So now I'm going to go to my next clue. The Pontiac finished 6 seconds after the Buick. Okay, so I have Pontiac and Buick here. If I look down at my diagram, I haven't actually plotted Pontiac or Buick on my number line, so I can't work with this clue yet. So I'm just going to skip it, and I'm going to go on down to the next clue to see if it's a bit more helpful. So the next clue says that the Dodge finished 8 seconds after the Buick. Again, if I look back down at my diagram, I don't have Dodge or Buick on there, so I'm going to go to the last clue. Hopefully that one will help me. So here at the last clue, it says the Chevrolet finished 2 seconds before the Pontiac. I do have my Chevrolet plotted on there, so I can work with this clue. So if the Chevrolet finished 2 seconds before the Pontiac, that means the Chevrolet is closer to the finish line than the Pontiac is. So I need to go back to plot the Pontiac. So here's my Chevy, and I'm just going to jump back 1, 2 seconds, and then I can put my Pontiac on here. And now that I've gone got Pontiac on my diagram, I can go back to one of those clues that we skipped. So take a minute and think about which one I can go back to. So I can go back to this clue right here because we see Pontiac. And it says the Pontiac finished 6 seconds after the Buick, which means the Buick is closer to the finish line. So when I jump my 6 seconds, I'm going to jump 6 seconds forward. So 1, 2, 3, 4, 5, 6, and I can now put my Buick here. And so now I can go to that last clue. The Dodge finished 8 seconds after the Buick. Okay, that means that the Buick is closer or further away. Take a second to think about that. So if the Dodge finished 8 seconds after the Buick has to be closer to the finish line. So I need to jump back 8 to plot my Dodge here, 8 seconds. So 1, 2, 3, 4, 5, 6, 7, 8. And there's my Dodge. And so now I've got my finishing order here. We've got the Ford first, the Buick second, the Chevy third, the Pontiac fourth, and the Dodge fifth. So it goes Ford, Buick, Chevy, Pontiac, Dodge, first, second, third, fourth, and fifth. So see how this compares to the diagram that you drew. And then, of course, we can't forget our fourth principle of reflection. So we're going to move on to that in the next slide. So as we know, whenever we reflect, this is one of the most important principles Polly gave us. The first question you should always ask yourself is, did this strategy work well? Was it efficient? Is there a better strategy? It's always worth asking ourselves this question. But in fact, I think this was a very efficient strategy. It was quick, it was easy. We didn't have to draw some crazy involved diagram, right? Number lines are very efficient. And then the second question I want to start getting you to think about at this stage, at the reflection stage, is what manipulatives could I use in the classroom, right? We always want to be thinking about this as teachers of young children or even as any mathematics teacher, because manipulatives help to take abstract concepts and make them more concrete. But the manipulatives that we choose are going to be driven by our students, their grade level, and their need. And so if I'm thinking about really young students who need to be actively involved in problems, one way we could solve this problem with them is to have them actually become the cars themselves and plot themselves on giant number lines and drive forward and backward and find out the finishing order. If we're dealing with students a little bit older, we might have taped these little number lines right here that you see on the screen to their desk or in front of them, and then they can use toy cars and drive them forward and backward. Going a little bit older still, maybe they have a giant number line on the floor in the classroom or one of these number lines on their desk. We can have them become a little bit more abstract and just use dots or jumps like we were using, or even sticky cards, things like that. And then of course our job as the teacher is to teach them how to transfer these sorts of experiences onto paper to record their thinking like we did. So lots of fun different ways, but we always want to be thinking about how can we get our students actively involved in solving this problem and what tools can we give them to help them understand it. And so manipulatives in the math classroom are really important. So it's just something we can always take a step back and think about at this point in the problem solving process. So now I'd like you guys to give this problem solving strategy a shot, applying it on your own using what we've just learned in the video. So go ahead and read through this problem, apply Polly's principles, draw your diagram, and see what you get.